students, let us look at the types of organic reactions. First I read out the handout, then I will explain. Okay. The types of reactions: a substitution reaction, where an atom or a group of atoms replaced by other group or group of atoms is called substitution reaction. It is of three types. It can be free radical substitution, for example, reaction of halogens chlorine, bromine, iodine, fluorine, etc. on alkanes. It can be SN reaction known as nucleophilic substitution reaction. In this reaction, one nucleophile, say X minus, replaces another nucleophile, say Y minus. It can be like SN1 reaction, where the speed of the reaction depends only on the concentration of substrate but not on the reagent. SN2 reaction, where the speed of reaction depends on the concentration of substrate as well as reagent. Third one is SNI reaction. Details of these reactions you study in class 12th. Next variety of substitution is electrophilic substitution. Here one electrophile, say H plus, is replaced by another electrophile, say M plus. These are the characteristic reactions of benzene. For example, when benzene reacts with a nitration mixture, nitric acid plus sulfuric acid mixture, H plus is replaced by NO2 plus. There are so many reactions of benzene called Friedel-Crafts reaction, sulfonation, etc. All these reactions involve replacement of H plus by different groups. They are called electrophilic substitution reactions. So what are the characteristic reactions of alkanes? Free radical substitution. What are the characteristic reactions of alkyl halides? SN reactions. What are the characteristic reactions of benzene? Electrophilic substitution reactions, sometimes called aromatic electrophilic substitution. Next, addition reactions. These are seen in compounds which have double bonds, like alkenes, like alkynes, like aldehydes, ketones. Wherever there is a double bond, it can be C double bond C or C double bond O or whatever. In the addition reactions, it involves a rupture of a pi bond and formation of two sigma bonds, while two atoms or groups are added to those carbons which lost pi bond. For example, CH2 double bond CH2. When C pi bond is broken, first carbon binds with H, second carbon binds with Br, then it is called addition reaction. This addition reaction converts an unsaturated compound into saturated compound. Now, this addition reaction can be electrophilic substitution. The speed of the reaction depends on the attack of electrophile, that is a positively charged species. For example, a reaction of HBr with alkene is called electrophilic addition. Second thing, nucleophilic addition. Here the speed of the reaction depends on the attack of nucleophile, say Cn minus, when HCN is added to aldehydes. The third thing is free radical addition reaction. When HBr is added to alkene in presence of light or peroxide, there is no electrophilic addition, it will be free radical addition. It means HBr breaks such that you get a H free radical, Br free radical due to peroxide or light. So HBr addition to alkene in presence of light or peroxide is free radical addition. HBr addition to alkene in the absence of light or peroxide is called electrophilic addition. Next, third category of reactions are elimination reactions. Elimination reaction is exactly opposite to addition reaction. In addition reaction, a pi bond breaks, two groups are added across the double bond. It means a pi bond is replaced by two sigma bonds. In elimination reaction, two sigma bonds on adjacent carbons can be broken to generate a pi bond. This reaction, where groups are removed, is called elimination reaction. Loss of two atoms or groups from a molecule is called elimination. If it happens from adjacent atoms, it results in pi bond formation. For example, when ethyl chloride CH3CH2Cl undergo elimination, HCl is eliminated so that you get CH2 double bond CH2. Again, this elimination reaction can be E1 reaction where the speed is dependent on concentration of only substrate. It can be E2 reaction that the speed of the reaction depends on both the fellows, substrate and reagent, or it can be E1 Cb conjugate base. The details of this perhaps you study in 12th class. If you look at CH3CH2Cl reacting with alcohol KOH, you are getting CH2 double bond CH2. So this type of elimination is called dehydrohalogenation because HCl is removed. If you are removing CH2Cl using zinc on heating, Cl2 is removed. This is called dehalogenation. If you are reacting simply alkane and heating it strongly, you are getting CH2 double bond CH2, H2 is lost, dehydrogenation. If ethyl alcohol CH3CH2OH is heated with alcohol KOH, you will be losing water, or when CH3CH2OH is heated with concentrated sulfuric acid, HOH water is removed, you get a double bond. That is called dehydration. So these are the elimination reactions. Finally, rearrangement. The molecule formula remains same, only there will be rearrangement of atoms. When ammonium cyanide is heated, you get urea.